Right, so we're calculating the internal volume of the box. We have the external measurements from part A. Last time we did 30 by 20 by 15. That gave us a volume of 9,000 centimeters cubed. Part B, we looked at the internal length, width, and depth of the box. These are these dotted lines, and we had these values in yellow, which I'm going to use to calculate the internal volume. So I'm multiplying 27 by 17 by 13.5, and that's going to give me a volume of 6,196.5 centimeters cubed. Now, part D is telling us that the box is made of silver, which has a mass of 10.5 grams for each centimeter cubed. Calculate the mass of the silver box, giving your answer in kgs. Now, the mass of that silver box will be the difference between my answers from part A and part C. So if we take 9,000 centimeters cubed and we subtract 6,196.5 centimeters cubed from it, that difference is going to give us the volume of the internal box, which I've tried to shade it in green in the diagram so you'd understand the region that we are calculating for. That's working out to be 2,803.5 centimeters cubed. Now, for every one of these centimeters cubed, we have a mass of 10.5 grams. So 2,803.5 centimeters cubed multiplied by 10.5 grams will give us the total mass of silver used. Multiply that by 10.5. You're getting a total of 29,436.75 grams. Now, they ask us specifically to express this in kilograms. 1 kilogram is 1,000 grams. And if you're going from a small unit to a big unit, you must divide. So if I divide 29,436.75 divided by 1,000, it's going to give us 29.43675 kgs. And that's how we're going to calculate the volume, the mass of the silver box, given our answer in kilograms. So moving on to the other question, we have here a diagram, not drawn to scale, shows two straight lines, JK and JL intersecting a pair of parallel lines, which is EF. So this is our parallel line here, EF and GH. JK is intersecting and JL is intersecting as well, right? Determine given reasons each of your following answers the value of X, Y, and W. So this is W here. This is X here. Y here. How we want to work this out. So what we could look at is we need to think about things like angles on a straight line. They sum to 180 degrees, right? We have to give reasons. Other than that, what else could we talk about? We could look at when we have these parallel lines, you also have to look for corresponding angles. Which are usually characterized by F shapes. Corresponding angles like this are equal. Yeah? We also have alternate angles. Do we have any alternate angles? Yeah, we have alternate angles as well too. Alternate angles. Looking for my line's looking kind of bend, right? Z-shapes that fix this property. We have two parallel lines and a line cutting through. Right, the Z-shape here and here. See, easy? They are also equal. So we're going to use these angle properties in order to work out our values for X, Y, and W. And one more is the sum of angles in a triangle is equal to 180 degrees. We're going to use that because we have a triangle here. This to find W is a triangle. So we can actually work out what our angles are here because we have straight lines in order to work out what this angle here would be. Right? We have a Z shape here. Right? As a parallel line, as a parallel line. Here we have a line cutting through. Bam. Right? So this angle here and this angle here be equal. After you work that out, you could use the angles on a straight line in order to work out your Y. This is a straight line here, so if you know what this angle is, this angle is going to be the same thing as well. Yeah? Another one that is useful as well when you do these, I'm going to write it here, is co-interior angles. And these are usually U-shaped. So inside of here and inside of here. They sum to 180. So if you know the value of one, and you could subtract that from 180 to find the value of the other. Yeah? All right, so let's talk about X. X is on a straight line and angles on a straight line sum to 180. So X is going to be equal to 180 degrees minus this. Right? That'll give us what? 52? 52 degrees. Right? What about Y? So if you look carefully here, we have the U shape that I was talking about. Just look for the parallel lines when you look at this. And you look for the shapes. This is a U shape here. So we have the co-interior angles that I mentioned. Right? You see the U shape? And co-interior angles also sum to sum to 180. So if X here, if you're writing this X here as 52 degrees, then Y is going to be 180 minus 52. Y is going to be 128 degrees. All right. Now to find the W, W is in a triangle. So angles in a triangle sum to 180 degrees as well. Right? We have two straight lines here. So if this is 100, then this is going to be 80 degrees. We already work out this to be 128, so this is 52. So W is equal to 180 minus 80 plus 52. So you have 180 minus 132. Right? 8 to make 40, 48. Yeah? Right. So in this question, we have transformation. Now, the three basic types of transformation is a reflection, a rotation, and a translation. Reflection is exactly like what will happen like if you look at yourself in a mirror. A rotation, we're actually turning it either clockwise or anti-clockwise. And a translation, another word for translation is a shift. We're shifting all the points either to the left, to the right, and up and down. So we could look at the diagram and we could rule out the ones that is not, right? If we look at the diagram RST and R prime, S prime, and T prime, the orientation pretty much remains the same. What I mean by that is that they're both still on this tip T here, right? If it was a rotation, then the triangle might probably turn this way, right? Because if you're rotating the image would, all the points will turn in a particular direction or a certain number of degrees. So it's not a rotation. It is neither a reflection, because if it's reflecting, we would get the opposite of each other. So it would look like this if we reflect it in the x-axis, for instance. So we know it's not a rotation, it's not a reflection. Then it's probably a shift. How can we determine that? Let's compare the points, right? So let's start with S. If we look at S, to go from where this S is here to where this one is, it actually shifts 2 blocks to the right. So this is more, any movement left and right is more X movement. So we could say this is a +2. To the right is going to be +2. And then my Y movement is up or down. But I'm shifting down to come down here. And I'm shifting down 1 block, 2 block, 3 block, 4 blocks. So that's -4. That's my Y movement. So far, if we just look at the S point alone, is a shift of 2 spaces to the right and 4 spaces down. Let's check the other points and see if that's the same. If it's the same, then we know it's a translation or shift. Let's look at R. R is also shifting 2 points this way, right? Look at it in order to line up with this R prime here. So that's a +2. And let's check how much down. 1, 2, 3, 4 down. -4. So again, we're good with that. R is also shifting by that translation vector. And let's look at T. T is also shifting 2 times this way in order to line up with this T. And then going on 1, 2, 3, 4. So same thing. So this is a translation, right? And we would describe that translation as being shift as, sorry, defined by the translation vector. The translation vector telling us the number of spaces to the right or left and the number of spaces up or down. And let's call our translation vector T. All of them are moving 2 spaces to the right and 4 spaces down. And that's how we would describe the transformation RST to R prime, S prime, and T prime. Let's look at the other part of the question now. The other part of the question says triangle RST. So we're talking about this triangle here now, RST, is reflected in the line X is equal to 6. So when you're reflecting something, you're going to have a mirror line. So they have to say what the mirror line is. In this particular instance, we are reflecting it in the line X is equal to 6. Now, any line defined as X is equal to something is always a vertical line, meaning it's coming from the top, coming down or up, down. And it'll be passing through the points X is equal to 6. So this is our mirror line. On the graph above, draw triangle R double prime, S double prime, T double prime, the image of triangle RST after the reflection. So we just briefly looked at reflection, right? Reflection is supposed to keep the same distance away from the mirror line. So if S is 1 block away from this mirror line, then this other value for S double prime will be here. Look at this. This is R is actually the distance away from the mirror line. 1, 2, 3, 4 blocks. So I'm doing the same thing on this side. 1, 2, 3, 4 blocks on this side. See that? And I'm also maintaining the size of the triangle. 3 blocks here, 3 blocks here. So you can connect these two. Right, this is R double prime. And then T. Look at the distance of T. T is 1, 2, 3, 4. The same thing here. 1, 2, 3, 4. See that? This here is my T double prime. Right? So that's our triangle. Write down the coordinates of R double prime. The coordinates of R double prime, if this is 9, we're moving in 1 unit increments. This here is going to be 10. And this is in line with 10 on the X and 3 on the Y. So R is 10, always X before Y, 3. Those are the coordinates of R double prime. So we have this question here where we have a diagram showing the graph of the straight line X plus Y is equal to 3. Now, the first thing with this is that we can't work with this equation of the line in the form it is currently in. X plus Y is equal to 3. That can't work, right? We need to change it to the form Y is equal to MX plus C. And to do that, we're just making Y the subject of the formula. So we're keeping Y on this side and we're moving the X up across. When we do that, though, the X is going to become negative X. This is important because in this particular form, it helps us to identify the gradient, M. And although we do have a number in front of it, this minus is a minus 1. So the gradient of this line that we're looking at on the graph, it has is a gradient of negative 1. Now the question goes on to ask us to determine the equation of the line, which is 1 parallel to this line that is given and passing through the origin. The origin is that point here in the middle, 0, 0. Right? So that's important because it's giving us the X and Y coordinates, right? Right. So it's giving us the coordinates that we'll use in our equation of the line formula. Right? The equation of the line formula that we will be using is the point slope form, which is Y minus Y1 is equal to M into X minus X1. So we want to get the values for Y1, M, and X1. Right? So let's write those out first. M is going to be negative 1 because parallel lines have the same gradient. So we establish our gradient to be negative 1. The parallel line going to have that same gradient. Then we need the points X1 and Y1, and we're getting that from the origin. X1 and Y1 is 0. So substituting those into our formula, this will be 0, this will be negative 1, this will be X, this will be 0. Expand everything out. Gonna get negative X minus anything by 0 is 0. Y is equal to negative X is going to be the equation of that parallel line. Right? So that's going to be a downward sloping line passing through. Gotta draw that line. Right? Y is equal to negative X. They come down, pass it through like that. Sorry, my bad. You know what the wrong thing. This way. Y is equal to negative X is a straight line, downward sloping and passing through our gradient. I could do a little better than that. Yes. Try to go. What? Y is equal to negative X. Bam, 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 bam. Right. That's how it look. See if I can get straight now. Maybe it's because of how copy the graph of course it's not lining up so well, but something like that. Right? Should run parallel to this other line here. quadrant, but they get the idea. Gonna be running this way. Like that. That's the best of it, really. Right, that's our parallel line y is equal to negative x. Right, parallel lines never intersect, same distance away from each other at all times. So that's what it would look like. Yeah. Part 2 now. Part 2 is talking about a perpendicular line to that original line x plus y is equal to 3 and passes through the midpoint of AB. Now they gave us these 2 points here, A and B. Right, and I wrote in what those coordinates are. A is going to be the point 0, 3, and B is going to be the point 3, 0. Right? Now, the midpoint formula that we'll be using, this is it here, midpoint x1 plus x2 over 2, y1 plus y2 over 2. So, I always like to write my values above, so I don't look too far for what I want to substitute. So 0 plus 3 over 2 and 3 plus 0 over 2. That's going to work out to be 3 over 2 and 3 over 2. You could leave it like that, or you could write it as 1.5 if that floats your boat. Right, but those are the values to the midpoint. The perpendicular lines. So perpendicular lines, right? For the gradient, you're gonna change the sign, and well, in this case, if we flip the number, we'd still get 1, right? So the gradient of our perpendicular line is +1, and the point we're using is 1.5 and 1.5, right? Honestly, I prefer to use 3 over 2 and 3 over 2, right? That's just my personal preference. X minus x1, our y value is 1.5, m is 1, our x value is 1.5. You're gonna get y is equal to y minus 1.5 is equal to 1x, okay, just 1x minus 1.5. And then I have to move this across it. So I get x minus 1.5 plus 1.5. Get y is equal to x. And now was the line draw incorrectly the first time. This is the perpendicular bisector here. See if I could get the line up. Going this way. Perpendicular. I'm going to draw the line initially and tell it that was a mistake. And this was the parallel line going through there. Right, so this one parallel. This is y is equal to negative x. And this is a nice illustration of what the lines y is equal to negative x look like. And this is line y is equal to x. Both of them passing through the midpoint. That's what it look like on the graph. Yeah? Next question, we have a function y is equal to x squared minus 2x minus 3. And the domain or the values to which we will be substituting for x is between -2 and 4. They gave us a table and they wanted us to find the missing values here and here. So basically, we are substituting x to be 1 and x to be 3 into our equation. So when x is 1, we will get 1 minus 2 minus 3. Working pairs, minus 1 minus 3, and minus 4. When x is 3, working pairs, 9 minus 6 will give us 3. 3 take away 3 will give us 0. Now they want us to then go on to draw this graph I'm gonna try and plot it right into this little space here. Right? One, 3, 4, 5. I'm looking at the highest y value that I have, which is 5. And my lowest y is -4. Right? So -1, -2, -3, and -4 down here. Let me see if I can do equal spacing. I'll go there. That's 1, 2, 3, 4. Now this is just a rough sketch, right? So hopefully our points and things kind of line up well. You will have a graph page to do this one. Right, so we plot in points. So we have -2 and 5. Right, so that's like here. -1 and 0, that's going to be here. 0 and -3, that's going to be here. 1 and -4, that's going to be here. 2 and -3, that's going to be here. 3 and 0, that's going to be here. And then 4 and 5 is going to be here. And then we're just going to draw a nice smooth line as best as we could. Right, and not too bad. And that's our graph, right? Remember, into the scale, you have a sketch. So I already have a scale because I freehand the drawing. Let's look at what they asked for in the rest of the question. Right, so they had given a graph page in the actual exam, right? So we drew the graph. Using information from your graph, complete each of the following statements. The minimum value occurs when x is. So this is our minimum curve. We could tell because first clue is that x squared is positive. If x squared is positive, then the curve is a minimum curve, meaning that it starts off descending, gets to a point, and then goes back up. So there's a minimum value or minimum turning point. We often say that once this value of x squared is positive, then the graph smiles. Right? Positive smile. If it was negative, x squared was negative, then it will have a frown and it will have a maximum curve. Right? So the minimum point occurs when x is, this point here, x is 1 and y is -4. So it occurs when x is 1. The values of x for which x squared minus 2x minus 3 is equal to x minus x plus 3, right? So what we want to do here is this is a line. Y is equal to minus x plus 3, right? And what we need to do is we need to draw this line on the graph. After we draw that, we want to look at the point of intersection. Now, how are we going to draw this line on the graph? Simple. This is the equation. And all we need is a little table of values. And we could use some of the x values that we have here. So let's use -1, -0, and a +1. When x is -1, right? I'm going to do it like this instead. Let's look at what negative x is, and then we'll add 3 to it. So negative, negative 1 will give me a positive 1. Negative 0 is still 0, and negative 1 will give me a negative 1. Let's add 3 to that. 1 plus 3 will give me 4. 0 plus 3 will give me 3. 3 minus 1 will give me 2. So look at the values that I have there. These are my y values. These are my x values. I have coordinates negative 1, 4, 0, 3, and 1, 2. Let's draw those on our graph. So negative 1 and 4 would be somewhere around here, right? 0 and 3 will be here, right? And 1 and 2 will be here. Now what we're going to do is we want to draw our line now. Passing through those points. Well, my graph was a kind of sketch, right? So if we had extended this a little bit more, we could kind of see that the points at which these intersecting is when x is negative 2, right? Look at that. And x is 3. So negative 2 and 3 will be my answer. Make sense?